All right, so let's get going on this second part of today's class. So before we get into doing ANOVAs, we need to take care of a little bit of administrative business, but a little bit of administrative business, specifically with the final exam. It's going to be Monday, June 24th at 10 a.m. That's our final exam. It's going to be in class. It's a final exam in name only. It's really just exam number 4. It's not cumulative. It's going to cover confidence intervals and chapter 10. So confidence intervals and ANOVAs. And that is it. So prepare for that. It's going to be a computational exam like all our other exams. It's going to be Excel, it'll be available in Canvas. 7-ish questions, I'm still finishing that up. And once again, it's going to be open book, which means open any resources that you want except other people. So get your notes ready, get your resources ready, print out your slides if that's what you'd like to do. And feel free to bring anything that you feel will help you be able to do confidence intervals and ANOVAs. And just to kind of make sure that you know what to expect, I did upload into Canvas this final exam template. So this is a template that shows you the type of questions that you will be asked. And you will only have questions of these two types on the exam. So type number 1 is your confidence interval questions. So you will get a description of a particular experiment. You will, from this description, determine whether the confidence interval is to be calculated with a single sample t-test, an independent means t-test, or a dependent measures t-test. And then what you will do is you will read which confidence level is being asked for, how much higher is group X and group Y, so in this case we're looking for a difference. You will be asked to provide a point estimate, the center of your confidence interval, and then you'll be asked to provide 2 confidence intervals of differing percentages. So it might be 95, 99, 90, 80. Make sure you read the confidence interval, calculate the, once again, the point estimate is your center, and then just calculate your plus or minus for the length of the arms of your interval. So that will be one type of question, and there'll be a number of those. And then your other type of question is going to be ANOVAs. And we're going to run through this in just a moment. But for this question, and once again, you'll read the description. It'll tell you which alpha level to use. It'll tell you which post hoc analysis to do. And we're going to learn about post hoc analyses in just a couple of minutes. And then you will have to fill in information for the 5 steps. So it will have your null hypothesis and your research hypothesis filled in for you. So just to complete the analysis, it'll have those filled in for you because it's just difficult to write those out and test them in an Excel format. So it'll have that written out for you. Step 2, your comparison distribution. What is your between treatments degrees of freedom? What is your within treatments degrees of freedom? We'll see how to where to find that. Step 3 is your alpha. Once again, early Christmas present. Get that from the question. Step 4 is your p-value. That is the probability that we will get from the ANOVA output. Step 5, you compare your p-value in step 4 to your alpha level. Make your decision. Same logic as when we were doing t-tests. And then the last thing is step 5, part B, will ask you to specifically compare different populations. And those are called post hoc analyses, and we're going to explain what those are in the next, in this part of the class. So that is it. It's going to be those 2 types of questions. Half of your exam is going to be confidence intervals. The other half is going to be ANOVA. So at the end of this second part of today's class, you will know how to fill out that confidence interval, the ANOVA question. The confidence interval, just like your homework that you just completed. So those are the kinds of questions that you'll see on the final exam. And then once again, to help you prepare, we're going to have a review session on Monday, June 24th. That's going to be the first hour of class, so that once again starts at 9 a.m. It's going to be an open review question, once again student driven, bring any questions, anything that you might want to see. And because of that, it's optional. So once more, for this final time, if you feel your time is better spent preparing in another way, even if it's just getting an extra hour of sleep, feel free to do that. Exam starts at 10 a.m. and you will receive an hour and a half for this exam. It's no longer than any of the other exams, but just we'll give you a little bit of extra time to complete that. All right, any questions on the final exam before we take a look at how to actually run and do an ANOVA?
I have a question.
Yep.
So you said like the worst exam would be 6%.
Yes.
So that's after we finish the final, so you will pick up. Okay.
Yep. So I've been updating your grades depending upon your exam scores throughout this semester. So after the first exam, when I projected your grade, that was your worst, your second, your third, and your best exam all in one. So basically your first exam was counted for all your exams in your projected score. Once you had your second exam, your best exam, I counted it as your first and second best. Your other exam, I counted it as your third and fourth best. And then once I finally get all four, then it'll be the complete kind of package. So yeah, so whatever your worst exam was, that's going to be worth the least. And that will not be calculated in Canvas. That's why for the exams, you'll notice it says does not count towards grade, because I don't have a way of calculating that or overwriting it. But in my files, in my Excel sheet, it does it automatically. All right, and in terms of kind of wrapping up the semester, I will be taking up exam number 3. We're still waiting on some makeups to be completed for exam number 3, so that's why we're not able to do it today. I will do that during the review session on Monday, so I will be handing back exam number 3 prior to that. However, we'll be taking it up as part of the review session. So if you want to see where it was that, or what the answers were for exam number 3, feel free to come in at 9 a.m. as well. All right, so one last little piece of administration before we get to the ANOVAs. The course evaluations are now available. I don't know if you received the message for that. I am going to put an announcement in Canvas, but I just wanted to mention it in class. So your course evaluations are available now to be completed. This is an important part of professors improving their course and maintaining quality of their courses. So when you're doing your course evaluation, if you could let us know things that worked, things that you found helpful. So for example, the MyLab, did you find the instant feedback helpful? Did you find the pretest helpful? I received enough comments to know that most students don't like the pretest, but if you found them helpful, please let us know. And then the YouTube videos also, if you found those helpful, let me know. On the other hand, things that did not work, you did not find helpful, let us know about that as well. So if you think the review session, could be better spent doing something else, I don't know, whatever it was, if there was anything that didn't work for you, let us know that, because I look at the course evaluations, I take that into account when I'm keeping things in my course and when I'm replacing things in my course. So because it's so important, I do offer a bonus of 1% towards your final grade for completing the course evaluation. So I will open up an assignment tab, and then once your course evaluation is done, if you can just save a screenshot or a PDF of your completion statement and just upload that to the assignment tab. If you've already completed your course evaluation, then just go back to where you kind of sign into your course evaluation, and it should say completed, and you can send that as your confirmation. If that doesn't work, just let me know, and we'll see if we can get that evidence. But it is an important factor in the design of this course. Much of what is in this course now is in there because of my responses to course evaluations. So like I said, let me know what I should keep, maybe something that didn't really work, and I will give you a bonus towards your final grade. All right, on to bird brains. So once again, we were asking the question, why do some birds migrate and other birds do not? So migration patterns, they can be non-migrating birds, they can be short distance migrating birds, they can be like the Arctic tern and migrate massively long distances, putting their lives on the line to try to travel across the globe. So researchers are asking, does this have anything to do with the intelligence of birds? So they used brain size to measure the intelligence of birds, and then they did an analysis to see if birds that do not migrate are actually smarter, more intelligent than birds that do migrate, as reflected or measured by their brain size. So we're going to take a look at how to do this with an ANOVA, and they needed to do an ANOVA on this because they looked at 3 levels of migration. They looked at zero migration, non-migrating birds, they looked at short distance migration, and they looked at long distance migration to see if there's any difference between birds that don't migrate, birds like the Arctic tern, and birds that might only migrate a short distance. Alright, so we're going to see how to do an ANOVA in SPSS. I'll mention the final homework assignment in Chapter 10 post-test because we do have that exam coming up. So there is a little weirdness with the due dates, a little uniqueness, as always happens with assignments before the exam. And then we're going to have lots of time for extra practice so you can try out your ANOVAs and make sure that everything is working as it should. Alright, so independent means ANOVA. Here's the situation. So one possible explanation for why some birds migrate and others maintain year-round residency in a single location is intelligence. Specifically, birds with small brains relative to their body size are simply not smart enough to find food during the winter and must migrate to warmer climates where food is easily available. Birds with bigger brains, on the other hand, are more creative and can find food even when the weather turns harsh. Following our hypothetical data similar to actual research results, the numbers represent relative brain size for the individual birds in each sample. We're going to use an ANOVA with an alpha of 0.05 to determine whether there are any significant mean differences amongst the 3 groups of birds. So here's our data here. So we have non-migrating birds. That is our sample from population 1. We have short distance migrating birds, and we have long distance migrating birds. And notice, just very quickly, that this is an independent means ANOVA because the subjects in one sample are different. That is independent from the subjects in another sample, and those are different from the subjects in the final sample. So it's an independent means ANOVA this time. And for the non-migrating birds, there are their relative brain sizes. Larger numbers mean higher proportion of brain size to body size. Here are the numbers for the short distance migrating birds, and then here are the numbers for the long distance migrating birds. There's our data, and we're asking ourselves, based on those samples, are there actual differences between the population of birds? Does the population of non-migrating birds actually have bigger brains than short distance, and do short distance have bigger brains than long distance migrating birds? Alright, so there's a situation. We're going to run an ANOVA because we have 3 levels, so we can't do a t-test anymore. Thankfully though, same 5 steps. So the hypothesis test is still the 5-step procedure that we've been using this entire second half of this semester. So let's start off with step number 1, restate the question as a research hypothesis and a null hypothesis about the population. Do birds that migrate shorter distances have bigger brains? That's the question we're asking. The null hypothesis is that brain sizes are not different for birds that migrate shorter distances. So there's no effect, there's no difference. And we can write that one out mathematically by saying that the average brain size for non-migrating birds equals the average brain size for short distance migrating birds equals the average brain size for long distance migrating birds. All the population means are equal. That's your null hypothesis, there's no difference. Your research hypothesis is that at least one of those populations has a different brain size. So at least one brain size is different for birds that migrate different distances. And that's the way that we write it up, because it might be that non-migrating are different from short migrating, and or non-migrating are different from long distance migrating, and or short distance are different from long distance migrating. It gets very complicated mathematically, This is saying at least one of them is different. So it could be one, it could be two, it could be all three, but at least one. And that's the opposite of the null hypothesis. All right, so we got our null hypothesis, we got our research hypothesis, covers all the possibilities, so we know that we've phrased it correctly. Number two, determine the characteristics of the comparison distribution. SPSS will do this for us. So the comparison distribution, your F distribution is defined by 2 degrees of freedom. You're within treatments degrees of freedom and you're between treatments degrees of freedom. So these can actually get complicated to calculate. So thankfully SPSS will do this. We just have to find out where to read it. Step number 3, set a cutoff probability. SPSS will not do this, but we have a cutoff probability for which is our alpha level. So this is much easier than looking up a cutoff statistic. So we have our cutoff probability of alpha. In your homework, you might need to look up a cutoff statistic. That would be in the appendix for the F distribution. But right here, we're doing it in the real world way. We're going to use a cutoff probability of alpha. That's given to you in the question. We have an alpha of 0.05. Determine your sample's probability on the comparison distribution. We're going to do that instead of our F statistic. And once again, our sample's probability is now a p-value. That's the probability of getting samples this weird if in fact there was no effect. All right, so SPSS will also do that. So right now we're ready to go to SPSS and set this up. So if you haven't already, your data can be found in 11B, that is practice June 19th, chapter 10. As always, there are screenshots of how to set this up and do the ANOVA, but let's do this live. So the data that you're looking for, let's get rid of this. The data that you're looking for is this data right here. So we got the bird brains, non-migrating birds, we got 6 of them. Those were their relative brain sizes. Short distance migrating birds, we have another 6 of them. Those are their brain sizes. Long distance migrating birds, we got another 6 of those. Those are their brain sizes. So what we're going to do is we're going to start taking this data, and once again we got to copy and paste it into SPSS. So we take our scores, and we go to SPSS, and depending upon whether you have this or not, we're going to copy that to the clipboard, and we paste it in, and we're going to label this brain. All right, so this is the brain sizes for non-migrating birds. Now, if you remember, in SPSS, when you were doing your t-test, what you would do is you would then have a second category, and you would call it something like non-MIG, right? So we'll call this non-MIG, and that identifies this as the non-migrating birds. All right, so we're going to call it non-MIG for non-migrating, and then we can put it up here, and let's call this MIG dist for migration distance. All right, this is the way that we would normally set this up. So let's continue on, and we have an independent means ANOVA, so the rule still applies, 1 subject per row. So these short distance migrating birds, they're completely new subjects, so they get a completely new row in SPSS. So we got to start them, we need to start them on row 7 so that they have their own row. And there we go. And we're going to call them short. And those are your, we're going to call them short, and those are your short distance migrating birds. All right, last one, we have our long distance migrating birds. We highlight their brain sizes. Remember that these are new birds, new subjects, different subjects, so they get their own rows. So we go here to row 13, we paste that in, and we can call them long distance migrating birds. Alrighty, so does everybody have that formatted? Does everybody have that set up? Okay, so the last thing we're going to do is in this third column here, we are going to write, we're going to number each group. And why we're doing this is going to become apparent in just a moment. So the non-migrating birds, we're going to assign them a number of 1. The short distance migrating birds, we're going to assign them a number of 2. And the long distance migrating birds, we're going to assign them a number of 3. So non-migrating, they're group 1. Short distance, they're group 2. Long distance, they're group 3. And I'm going to write that up here so that I have that as a record. So non-migrating, they are number 1. Long, they are number 2. And then short, they are number 3. And why we're doing this is going to become apparent right now. So we have our data set up. Oh yeah, and before we get to that, let's change that variable there to migrate. Okay, so that's the migration group. All right, so we have our data all set up, ready to go. We go back to analyze, we go back to compare means. So we're still in that same area where all our t-tests were. And we're looking for independent means ANOVA. SPSS does not call it that. It calls it a one-way ANOVA. So the test that we're looking for is in analyze, compare means, and it's called one-way ANOVA. So make a note, that's the one that we're looking for, one-way ANOVA. When we click on it, we need to, first off, let the one-way ANOVA know where our scores are. So the first thing it's going to ask us for is this dependent list. This is where our scores are. This, in this case, is where our brain sizes are. So we're going to go here, and we're going to click on brain, and we're going to move it into the dependent list, telling SPSS the variable called brain is where you can find all your raw scores. The next thing we need to do is we need to fill in this factor down here. This factor is our groups. This is how SPSS is going to identify the groups. But notice, SPSS is being a little weird, and it's not letting us do what we practiced so many times with the t-test. So if you recall, for the independent means t-test, at this point, we would move the names of the groups into that factor window, and then we would define those groups. We would let SPSS know, oh, group number 1 is called non-MIG. Group number 2 is called short. Group number 3 is called long. But notice, it's not allowing us to do that. We don't have this MIG distance variable even available to us. We only have this migrate distance. So don't ask me why. I don't know. But for some reason, for the ANOVA, you have to label your groups with numbers. They have to be labeled number 1, number 2, number 3, number 4. However many groups you have, it has to be labeled with numbers. And I'm showing you this and making a big point about it because we have gotten so practiced for an independent means hypothesis test of labeling our groups with words, with names, that this is a little shift that sometimes confuses students. So for example, if you're trying to run a one-way ANOVA and your group names are not showing up and you have nothing in this box here, just remember you have to number your groups for the ANOVA. And then the other thing you're going to want to do, and this is extremely important too, is you're going to want to write down those numbers somewhere. Because we're going to have to juggle a lot of information in our minds later on when we're doing post hoc analyses. So you want to be able to offload this from your working memory, write it down. You think you're going to remember it. You're taking a chance if you just rely on your own abilities and your own memory. So just write it down, offload your mind will thank you, and you'll be able to do the test correctly. As it is, we need to tell SPSS down here in this factor window, what are your names of your groups? So we labeled them. Group number 1 is non-migration. Group number 2 is short. Group number 3 is long distance. Pop that into your factors, and we're ready to go. The last thing we're going to do is we are going to, no. All right, so why don't we do it right now? That'll be enough for right now. So we put brain as our dependent list. That's where our raw score is in. Factor is our migrate numbered groups. And we're good to go. We hit OK. And we get our ANOVA. Let me just back up one time. I knew I was forgetting something. Sorry about that. Analyze, compare means, one-way ANOVA. We're going to go to options. We want descriptive. That's the last thing I forgot. We want descriptive. Descriptive is going to be our double check. We don't need to do it, but it's a good idea to do it, especially for the ANOVA. So we're going to click on descriptive. We hit continue. So that was in options. Make sure descriptive is clicked. We hit continue. We hit OK. And there's what I was looking for. All right, so there's our output for our ANOVA. Does anybody not have this output? All right. So we have our output. We are all done. So let's analyze this and see where we can find all of our information. So we get our output. All right, so now we need to find each part of what it was that our 5-step hypothesis test is asking us for. So one of the first things to do is step 2, determine the characteristics of your comparison distribution. So for step 2, we need the degrees of freedom for the within, and we need degrees of freedom for between. All right, step 3, we need our alpha level. We get that from the question, that's 0.05. And then finally, step 4, we need our p-value, and we'll see where to get that as well. All right, so starting off with step 2, the comparison distribution. We go to our table, and actually before we even get to our comparison distribution, we do want to compare or make sure and check our descriptives. So this table up here, we want to check that out because it is very, very easy to make an error in an ANOVA when you're labeling your groups. So the first thing you want to check is you want to check that you have the right numbers in each group. So we have group number 1, non-migrating, right? Write it down, it's useful. Group number 1, we got 6 birds. Group number 2, we got 6 birds. Group number 3, we got 6 birds. When you're running through and entering your data and you're going 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, it is so easy to go 1 extra or 1 too little on some of your groups. I can't tell you how many times I've run an ANOVA, checked this, and found out that one of my groups was missing a data point, and the other group had a data point. So ask for the descriptives in the options, check on it, look to make sure that you got the right numbers in each group, look to make sure that your means are correct for each group. So SPSS will calculate those mean scores for you. Just do a quick double check, again, because when you're labeling those groups very quickly, it is very easy to go 1 subject too far for one of your groups. All right, so we checked our numbers, they're good. We checked our means, they're good. Now we're ready to fill in some of our hypothesis testing information. So we need within treatments and between treatments degrees of freedom. That's going to be found down here in this table, very nicely labeled ANOVA. And you can see right here, it tells you the sources of variance. So this is between groups, within groups, and then total. You will see between treatments and between groups about 50-50 depending upon the stats that the text that you're reading. It's the same thing. What you want to look for is between. So between treatments, between groups, same thing. Within treatments, within groups, same thing. You're looking for between, you're looking for within. Those are the key words. So we need our within degrees of freedom, and that information is given right there. So we read off of the table, within groups has 15 degrees of freedom. So we pop that in here, 15 for within degrees of freedom. Between groups has 2 degrees of freedom. We pop that right in there. And we have determined the characteristics of our comparison distribution. Alpha level, right there, that is the line in the sand. That is our probability line in the sand. And for your homework, it will ask you for an F statistic occasionally. SPSS will calculate that out for you. They're kind of getting this backwards. SPSS will calculate that out for you right there. So your F statistic, much like your T statistic, but labeled F for ANOVAs. Your F statistic in this case is 19.286. And that F statistic on your F distribution gives you a probability, in this case, of 0.000. So there's too many decimals to put up there. So we'll just put that in, 0.000. That's the significance. That's the probability of getting samples this different if all the birds have the same brain size. That's what that probability is. So we have all the information here filled in. Last thing we're going to do is we're going to compare our samples probability to our alpha level. And again, it's the same logic. If your p-value is less than your alpha, our p-value is 0.0000 something all the way down there. Our alpha level is 0.05. Yes, our p-value is less than our alpha level, so what do? We accept the research hypothesis and we reject the null hypothesis. If, on the other hand, it was the opposite, if our p-value was greater than our alpha value, then we would accept the null hypothesis and reject the research hypothesis. As it is, we reject the null hypothesis. We got a p-value of 0.00. We got an alpha level of 0.05. Reject the null hypothesis. Reject the idea that there's no difference between the brain sizes of migrating birds. And we can conclude, we can accept the research hypothesis, we can conclude that at least one brain size is different for birds that migrate different distances. And unfortunately, that is all that you can do with the ANOVA as we set it up. So it's not the end of the story, but I wanted to get to this point here because an ANOVA tells you that there is a difference, but on its own, it doesn't tell you what is different. So it lets you know that one of these populations, at least one, is different, but it doesn't tell you which one. It doesn't give you that information. So this is not very useful on its own as it is. And just to kind of show you this, give you an example here. Let's say that you were running an experiment and you were working for a drug company and your boss says, I need you to run this experiment. We're coming out with 3 new versions of this drug to treat, to treat cancer. So you need to do some clinical trials. So you set it up and you have a placebo and you got drug A and you got drug B and you got drug C, right? So you got the 3 treatments and you got the placebo for the control and you run your statistics. And let's say that we're using an alpha level of 0.0001 because this is a drug test. And let's say that our p-value comes back and it is less than our alpha level. So we have a significant effect, right? Our ANOVA has released a significant effect. So you run back to your boss and you say, oh my gosh, we finished the experiment, we've done the trial, I've done the stats, significant, right? We found a significant effect. At least one of these drugs is better than the other ones. And your boss is like, oh my gosh, that is amazing. Which drug? And you say, I don't know. I don't know which one is the good one. But one of them is really good. It's not helpful, right? I mean, it's it's frustrating if that was all that we can do. So right now we found that there is a difference in brain sizes somewhere. So we got to augment the ANOVA to find out which brain sizes are actually different. So which brain sizes are different than the others? Is it that non-migrating birds have different brain sizes than short-distance migrating birds? Is it that non-migrating birds have different brain sizes than long-distance migrating birds? And or maybe short-distance migrating birds have different brain sizes than long-distance migrating birds? Which one of these is it? Well, for that, we have to go back and we have to do post hoc tests. So we are going to show you now how to do that post hoc test. And we are going to use the one of the most popular ones, which is the Tukey honestly significant difference test. So for this, we are going back to our ANOVA, and we're going to go, we already have our data, so we go back to analyze, we go back to compare means, we go back to the one-way ANOVA, everything's already set up, but now instead of clicking just OK and running our ANOVA, we're going to click on, not options, we're going to click on post hoc, and that will bring up this selection window for which post hoc analyses do you want to do. So there are a number of different post hoc analyses. Post hoc means after the fact, and this is basically after you found a significant difference in your ANOVA, after you found a significant effect for your ANOVA, then you do this analysis. You do a post hoc, you do it after the fact. And they are different ways of controlling for that alpha experiment-wise inflation, but doing the comparisons between each condition. So there are a number of different ones that are very well-known or often used. Tukey is one of them. The Tukey honestly significant difference test is very popular. Bonferroni, the San Francisco treat, is also very popular. The one that I use is SIDAC. You will learn more about which test has pros and cons later in your academic career, maybe in grad school when you take a statistics course. For right now, it'll be told to you which test to use. So in your homework and in the exam, keep an eye out and it'll let you know, oh, run this with an alpha level of 0.05 and use Tukey, honestly significant difference, for the post hoc analysis. Use Bonferroni for the post hoc analysis. The questions will tell you which analysis to do. So for this one, we're going to use Tukey, the honestly significant difference. And the one thing that you don't want to do when you're doing these tests, and this is just for your future analyses, never click on all of them. They all have pros, they all have cons. Some are good in some situations, some are better in others. But you never want to click on all of them because your output will be 80 pages long and you will have difficulty finding the test that you're looking for. So at most, maybe choose 2, but we're going to choose Tukey because that's what the question asked for. And then the last thing that you want to do before you hit continue is go down here and make sure that your significance level for your test, for your post hoc analysis, equals your alpha level. And this is a very nice thing that SPSS does for you, which is a nice double check for your interpretation. It will actually help you in interpreting your post hoc analyses. So we check our significance level, it's 0.05, that's the default. We see that we have an alpha of 0.05, so that works for us, so no need to change it. So once that's all set up, we want Tukey, we have a significance level of 0.05. We hit continue, and now that we're asking for a post hoc analyses, we can hit OK. And SPSS runs the exact same ANOVA, so it gives us the exact same output that we had before, but this time it's added this post hoc test here. So this time, because we asked for it, it has given us this post hoc analysis, this after the fact analysis, and this is what's going to tell us which population of birds is different from which other population of birds. This is going to tell us where did our results, our significant results, actually come from. All right, so we have this output. So now we got to interpret it. And we'll zoom in on there. And one of the first things to notice is that SPSS is actually very friendly on the post hoc analyses. So it tells you which post hoc analysis you did. So when you choose Tukey, it's called Tukey in the menu, but that's the Tukey honestly significant difference test. So that's the one that your homework will most likely use the most often. And it just reminds you, hey, that's the test that you did. You did the Tukey honestly significant difference test. All right. The other thing to realize about this output is that for some reason it's redundant and non-redundant at the same time. So you'll notice that it compares one group to another group, right? So in the table. So for example, this first row here compares group number 1, whatever they were. Oh, right, I wrote it down, non-migrating. It compares group number 1 to group number 2. So non-migrating to long-distance migrating. It compares them in this first row. This second row here is still group number 1 compared to group number 3. I don't know why SPSS thought it would be helpful not to print out the numeral 1 there to make it easier. But just so you know, this is still group 1 versus group 3. This table gets redundant because up here we have group 1 compared to group 2. And then down here we got group 2 compared to group 1. So use it as, you know, as it is. It duplicates a lot of information. Don't get confused about that. And we're going to see how to read this table now to answer where did this difference that we found, where did it come from? Which populations are responsible for this? All right, so as I mentioned, in that first column, we are comparing one group to another group, right? And then it'll say which group is being compared, which two groups are being compared in each row. The next column over computes your mean difference. This is just the difference between the two groups. So the difference in scores between group 1 and group 2 is 6, right? So their raw scores had a mean difference of 6. Importantly for us is this column right here. This column labeled significance, that is just like a p-value. So you can think of this table as just a list of a whole bunch of t-tests, almost. They're not exactly t-tests, they're Tukey post hoc tests, but they work like t-tests where you compare two samples and come up with a significance. What's the probability that there is a actual difference between the populations? This is the column that we're going to focus most on. All right, so first thing we want to know is there a difference between non-migrating birds? One second, I got those numbers wrong, didn't I? Let me take a look. Yep. So when I said that you needed to write things down, you also need to write them down correctly. That makes more sense. Short and then long. All right, yeah, so make sure that you write those down correctly. Otherwise, offloading them off your brain, not going to help. Okay, so back to the analysis. The first comparison that we want to do is we want to compare are the brain sizes for non-migrating birds different than brain sizes for short migrating birds? Is this one of the places where the populations are different? Is this one of the places where we found that significant overall ANOVA? So we need to find where group 1, sample 1, is compared to sample 2. That is in row number 1. And we can see that the significance for that comparison is 0.003. That is your probability for that comparison. So this comparison right here, the p-value for it is 0.003. This is compared to the alpha level. So much like we've been doing this entire time on hypothesis testing, we take a look at this. If your p-value is less than your alpha value, you reject the null hypothesis. You reject the idea that there's no difference between these two. That's what we're doing. We're saying that there is a difference between these two. One of the differences in this experiment is that non-migrating birds do not have the same brain sizes as short distance migrating birds. That's one of our conclusions. So we say that there's a significant difference, and we get it from this p-value here. As a double check, you're going to want to go over to this mean difference category right there, and you're going to want to look for an asterisk, because that asterisk means that the mean difference is significant at the 0.05 level. And this 0.05 here, this is whatever you entered into the alpha level for your post hoc analyses. So remember when we were choosing the Tukey test and we entered in 0.05? That's what it is. That's where this 0.05 came from. So that's a nice double check, right? Based on the p-value, based on the significance level, we conclude that there's a significant difference. And SPSS is saying, yeah, I think so too. There's your asterisk. So it's a nice double check just to kind of make sure that you're not misinterpreting things. All right, so this post hoc analysis reveals, the first one reveals that non-migrating birds have different brain sizes than short distance migrating birds. So that's one of the places where this difference came out. So we got to do the other ones as well. So let's take a look at non-migrating versus long distance migrating birds. So this time we're doing those two. So for that we have to compare group 1 to group 3. So we find a row that has group 1 and group 3. That's that row right there. Don't get thrown off by the fact that there's no 1 there. The 1 kind of carries down, so that's group 1 versus group 3. So once again, we go over here to this significance value. This has a p-value of 0.000. Once again, this is less than our alpha, so we reject the null hypothesis. We see that there is a difference between non-migrating and long-distance migrating birds. And then we use the SPSS double check. Right there is that little asterisk, and SPSS says, yep, I agree with you. There is a mean difference significant at the 0.05 level for this comparison. So in that case, we now know that in addition to non-migrating birds having larger brain sizes than short distance migrating birds, non-migrating birds also have larger brain sizes than long distance migrating birds. So non-migrating birds were different to 2 populations. Are all 3 populations different? Well, for that we have to compare short distance to long distance migrating. So we now compare the final comparison, short distance to long distance, and for that we need to find group 2 versus group 3. There is group 2 versus group 3 right there. We scroll over here to the significance and we find a p-value of 0.138. So we got a p-value of 0.138. We compare that to our alpha. This is larger than our alpha. So we do not accept the research hypothesis. We accept the null hypothesis. We determine that there is no difference between the brain sizes of short and long distance migrating birds. And as a double check, we go over here to this mean difference column and notice no asterisk. So SPSS is also saying, yeah, I agree with you, there's no asterisk. This is not significant at the 0.05 level. You know, that's your double check there. So that completes our analysis. As it turns out, short distance migrating birds and long distance migrating birds have the same size brains. The only difference is with non-migrating birds. So in short, the story is that if you're intelligent enough as a bird, you will not migrate. But if you're not intelligent enough, then you'll migrate. And it doesn't matter if it's a short distance or a long distance, it's your brain size that determines whether you migrate, but not how far you migrate. And that comes out of the post hoc analysis. So once again, the ANOVA told us that there is a difference. And then the post hoc analysis told us where that difference comes from. All right, are there any questions on ANOVAs doing post hoc analyses? All right, so a couple of things to wrap up. Now that we have gone over the ANOVAs and post hoc analysis, your exam will make a little bit more sense here. Oh, sorry, the exam template, let's hope the exam makes more sense, but the exam template will now make more sense to you. So I'll bring it up once again. So you will have half of your exam will be these ANOVA type questions, and you will once again be given the null hypothesis and the research hypothesis. So now you can appreciate why you're not being asked to fill that in. You're just being given those. You'll be asked for the degrees of freedom for between treatments and within treatments. Remember, it's degrees of freedom between treatments or groups. Different places call it treatments, different places call it groups. And then within treatments or groups, different places call it treatments, different places call it groups. And then your alpha level, you get it from the question. Again, early Christmas gift. Your p-value, this is your significance level for your alpha test, sorry, for your ANOVA test. You get that from your SPSS output. You compare your p-value to your alpha level, and you decide whether to accept or reject the null and the research hypothesis. And then in the question itself, I will let you know in that last sentence there, number one, what your alpha level should be, and then number two, which post hoc analysis to do. So in this case, I'm asking you to do a two-key, honestly significant difference post hoc analysis. Remember, that is the two-key option. I might ask for a SIDAC, I might ask for a Bonferroni. Make sure that you click on the right option for that analysis. And then the last part of this analysis, part 5B, I will ask you if there is a significant difference between specific populations. So for the exam, there might be only 3 levels, in which case I will ask you all 3. Or there might be 4 levels, 5 levels. I will not ask you for all of them, all right, because for 5 levels, there would be 24 possible comparisons. That's way too much to have you go through. So I won't ask for all of them. I'll ask for specific ones. So for example here, I'm asking you, is there a difference between the BLA-W and BLA-X patients? So make sure that you have written out somewhere how you've numbered these so that you can easily go to the table and say, all right, BLA-W is 1, BLA-X is 3, so I'm looking for 1 versus 3, and then you interpret your table in that way. So that is what half of the exam is going to be, questions on the ANOVA, and that is the information that I will be asking for. All right, so let's wrap up this portion right now. So we do have that exam coming up Monday, all right, so please do not come here on Tuesday. I'm going to put out an announcement for that just to make sure. It's on Monday, so because of that, we got a little bit of weirdness with when the homework and the post tests are now going to be due. So homework assignment number 14, this is your chapter 10 homework. You are ready to go for this. That is going to be due Friday, June 21st by 12:15. So basically, at the end of this class, you got 48 hours to complete your homework. And that'll give you enough time to get some feedback and have the weekend to study for that. Your chapter 10 post test is going to be due Sunday, June 23rd. Once again by 12:15, so you have 96 hours to get your post-test done. And again, we're putting it early like this so that you can get your post-test feedback in time so that you have just under a day to review any information that you might get from your post-test. And then your pre-test study points, your MyStatLab mastery points. For Chapter 10, that is due by Sunday at midnight. So that's the day before the exam at midnight. That's pretty standard. We just want to let you be aware that if you didn't get 100% on your Chapter 10 pretest, you can complete those mastery points to earn 100%, but that will be due by midnight the day before the exam. All right, so that is basically it for what I wanted to cover today. So because we have this exam coming up, because ANOVAs are a new big hypothesis test, and because the confidence intervals incorporate all 3 t-tests that we've done before, I've decided for the last part of today's class to be devoted entirely to practice. So there is extra practice. There's a practice problem for Chapter 10 analysis of variance. Analysis of variance, it has to do with keyboard designs. So there's 3 different keyboard designs. You're being asked to determine which one is best. So there's a description. There is the output that you're looking for. There is the answers for each particular section and for the post hoc analysis. So I highly recommend give those a go. Try that out. Make sure that everything is working. Especially make sure that you know how to read that post hoc analysis table. And then you can also get started on your homework. So basically the last hour and 15 minutes of today's meeting will be dedicated to practice time. It has been a long semester. I will not judge if you decide to make it an early Wednesday today. But if you want to stick around, I will be available and to answer any questions that you might have about the ANOVAs. Other than that, we are done for the semester. So I will see you all here for the exam. And let me know if you have any questions.